This is an example that's on page 614, but let's go through it. So they look at two different schools and want to know if kids are eating breakfast. So, school 1, they took 80 kids, 19 had not eaten breakfast. School 2, they took a simple random sample of 150 kids, 26 had not eaten breakfast. And we are going to look at this. What is the difference between these two schools? Like that. Now, significance level of 0.05. So now we're doing a significance test on this thing. And what's the deal? Oh, we just want to know if they're different. We don't want to know if school 1 is higher or lower. So this is one of those two-tailed tests, not equal to. Okay, so when we get the p-value, we're going to have to multiply it by 2. Don't forget that. So times 2 when you see that. We figure out that not equals 2. Okay, let's get started. So let's see. Calculated the two proportions, and they're off a little bit. Let's see how far they are off. Does that seem kind of weird? So here's the thing. What is the null hypothesis? So basically what we're going to say is if we subtracted the two schools and they were equal, what would you get as an answer? Well, 0. That means no difference, right? No change. They're both the same. And then what we're going to say is, so that's our null hypothesis, right? And then our alternative hypothesis is going to be p hat 1 minus p hat 2 is going to be something other than 0, right? That's our alternative hypothesis. Okay, so that's a good thing to get used to. All right, now let's go to the next thing. So now we have another standard deviation. Now this is used just for a significance test. We're going to keep the other one for the confidence intervals. So here's the deal. What we're going to do is we are going to combine our two samples. Sometimes they call it pooled. Okay, and so we take the 19 kids and the 16 kids from the two schools, and we're going to add. Remember, if you take a bigger sample size, you're bound to get more accurate results. So we kind of want to estimate the proportion for the entire population, but we are comparing the two different schools from this population of kids that go to school. I guess that's the best way I can explain it. And so here's what it looks like. Our new standard deviation is going to look like this. So it's this pooled data, right? And 1 minus that pooled stuff over the first population, right? So that would be over 80. And then add that, the pooled, and same thing, right? It's going to be the same number. Like that. Over the other population. Sounds crazy, right? But that's what we do. So let's do it. So there's all the numbers, right? So add these two together, add those together, divide them, here's my number. And there it is. 1 minus that number is right there, divided by the population of the first school. Same thing, right? The pooled data and the pooled proportion over the other school. Now I put all that stuff into that big fraction thing that Casey showed us, and I get, what is it? 0.0549. Okay, there's all that stuff. Now, what do we do with it? Well, we got the standard deviation, right? Well, we got to get a z-score. So let's go to the next page and take a look at that. So let's see, z-score, right? Here we go. The z is going to be, well, we're going to subtract the two proportions. What were they? 0.2367. 0.175 for the first one and 0.1733. Subtract the two proportions minus what we kind of expect them to be if the null hypothesis was true, would be 0, and then the standard deviation, which was 0.0549. So for this thing, you end up getting 1.7. Oh no, it's 1.17. That's our z-score. So what do we do with that? Well, normal CDF and see what's above that to begin with. So remember, I love drawing these pictures. Right here we are at 0, and we're at 1.17 standard deviations. How much of the area is above that? Well, I put it in normal CDF, subtracted from 1, and I get 0.12. Now don't forget, this was a two-tailed test, right? So we want to know on both sides. So we got to multiply it by 2. So of course, 2 times 0.12 gives us 0.24. Okay, what do we do with that? Well, if the null hypothesis was true, there's about a 25%, 25%. 1 out of 4 times we would get a difference like this if the null hypothesis were true. Now, we're not going to say that the null hypothesis is true. We're just going to say we're going to fail to reject the null hypothesis. We do not have enough evidence to say that the kids at these two different schools are different about how they, or when they, or why they eat breakfast. Okay. Weird standard deviation, huh? So, 2 different ones in this case. One for the confidence interval and one for the significance test. So there you go. That's what we're going to do tomorrow.